Hello, this is lesson 6 in the series of 10 lessons where we are learning about the area of different quadrilaterals. So, in this lesson 6, we are going to learn how to find the area of a trapezium. And as we said in the previous lessons, area is the region enclosed by the sides of any quadrilateral you are given, and in this case our quadrilateral is a trapezium, so the area is this region here enclosed by the sides of the trapezium. So the area of a trapezium is given by half into A plus B, where A and B are the parallel sides of the trapezium, then multiplied by the height, where the height is this one here. So with that knowledge, can we try to solve some questions relating to the area of a trapezium? So in this first question, you are told a trapezium has parallel sides of 10 centimeter and 6 centimeter, and then a height of 5 centimeter. Find the area. But we already know area of a trapezium is given by half into A plus B, where A and B are the parallel sides, then multiplied by the height. So here we are given the A, which is 10 centimeter, and B is 6 centimeters. So A is 10 centimeters, then B is 6 centimeters, and then the height H is given by 5 centimeters. So to get the area, we need to say area A is equals to half into, you already know A is 10 centimeters, then plus B, which is 6 centimeters, then multiplied by H, which is 5 centimeters, like that. So from there, we can take this half into 10 plus 6, which is 16, then multiplied by 5, like that. Then we can open this brackets here and divide by 2, 1. By 2, 16 divided by 2 is 8. So now it becomes 8 multiplied by 5, which is 40 centimeter squared. And then becomes the area of this trapezium. Can we try another example? In this example, you are told a trapezium has parallel sides of 14 centimeter and 8 centimeters, then a height of 7 centimeters. Calculate the area. As we said, area is the region enclosed by the sides of the trapezium, and our height is that one in a trapezium. So to get the area, A, we said, is given by half into A plus B, where A and B are the parallel sides, then multiplied by height. But we are already given the A, we are given the B, and we are also given the height. So the values are 14, 8, and 7. 14, 8, and 7, like that. So to get the area of this trapezium, we have to get a half into, you already know A is 14, then plus B, which is 8, then multiplied by H, and our H here is 7. So instead of putting H, let me put 7 here. So it will be 14 plus 8 is 22. So now it will be half into 22 multiplied by 7. This equals to this half I divide by 2, 1 by 2, 11, because 22 divided by 2 is 11. Then 11 multiplied by 7 will be 77 centimeter squared, and that becomes the area of this trapezium here. Can we try another example? Sometimes you can be taught to find the area using algebra. Like in this case, you are told a trapezium has a parallel sides of x. So this side here is x, then 6 centimeters. The other one is 6 centimeters. So here is x, then b is 6 centimeters, and then height of 4 centimeters. And then you are told to write an expression for the area. So of course, the area we are looking for is the region enclosed by the sides of the trapezium. That one. And from this information, we know our hair. Let me clean the board first. We first of all know area of a trapezium is given by half into a plus b multiplied by height, like that. But in our case, we know a is x and b is 6, and then we know the height is 4 centimeters. Height 8 is 4, like that. So to get the expression of the area here, we'll have to replace all those values in the formula. So we have half into, we know here is x, then plus, we know b is 6, then multiplied by h, which is 4, like that. But you see, before we open these brackets, we can divide this 2 here by 2, 1 by 2. This 2 here of height becomes 4 divided by 2 is 2. So now the area becomes x plus 6 multiplied by 2, like that. So to open the brackets here, we need to take these 2 and multiply it with each of the values inside the brackets. So now it becomes, it's just like writing like this, 2 into x plus 6, like this. So when I open the brackets, it will be 2 multiplied by x, which is 2x, then plus 2 multiplied by 6, which is 12. And this becomes the area, the expression of the area of this trapezium here. Sometimes also you can be told, you can be given the area itself, then you are given mainly 2 of the sides and you are told to find the remaining side or the height. Like in this case, you are told in this question here, you are told the area of a trapezium is 120 centimeters, then the parallel sides are 12 centimeter and 8 centimeter. Find the height. So the first thing we do is, of course, we know area A, our trapezium is given by half into A plus B, but now multiplied by height, like that. But in this question here, of course, area is that region enclosed by the sides of the trapezium, then that is the height we are being asked. Then from this one, I know the area itself is 120 centimeters squared, so here is 120 centimeter squared. Then A, the parallel sides A and B are 12 and 8. So I know A is 12 and B is 8. Of course, centimeters this here and B. Then we are asked to find the height. We don't have the height. Yeah. So we already know from the formula area is 120 is equals to half into a plus b, but we already know a is 12, then plus b, and we know b is 8, then multiplied by height, but we don't have the height is the one we are asked. So from there, I can say 120 is equals to half into 12 plus 8, which is 20, multiplied by the height, this one. So I can divide this 2 by 2, 1 by 2. This one now becomes 10 because 20 divided by 2 is 10. So now it becomes 120 is equals to 10 multiplied by h, which is 10 h, like that. But now to get the h itself, we need to divide both sides by 10, like this. So it becomes 120 divided by 10, it will be 12. So, and here I divide by 10, 1 by 10, 1. So the height will be 12 centimeters. That becomes the height of this trapezium here. So that's how we find the area of a trapezium. If you have any question or there is a place you did not understand, you can ask me in the comment section, and let us meet in lesson 7, where we explore the area of a different quadrilateral. And bye for now.